Energy Security Act was introduced for the first time. Sorensen had urged this measure since 2006. Benefits: abundance. Thorium is 3 times as abundant as uranium and nearly as abundant as lead and gallium in the Earth's crust. The Thorium Energy Alliance estimates there is enough thorium in the United States alone to power the country at its current energy level for over 1,000 years. America has buried tons as a byproduct of rare earth metals mining, notes Evans Pritchard. Almost all thorium is fertile Th232, compared to uranium that is composed of 99.3% fertile U-238 and 0.7% more valuable fissile U-235, less suitable for bombs. It is difficult to make a practical nuclear bomb from a thorium reactor's byproducts, allowing governments to potentially pursue further nuclear power without worsening nuclear arms proliferation. Thorium is not fissile like uranium, so packed thorium nuclei will not begin to split apart and explode. However, the uranium-233 used in the cycle is fissile and hence can be used to create a nuclear weapon, though plutonium production is reduced. According to Alvin Radkowsky, designer of the world's first full-scale atomic electric power plant, a thorium reactor's plutonium production rate would be less than 2% of that of a standard reactor, and the plutonium's isotopic content would make it unsuitable for a nuclear detonation. 11. Several uranium-233 bombs have been tested, but the presence of uranium-232 tended to poison the uranium-233 in 2 ways. Intense radiation from the uranium-232 made the material difficult to handle, and the uranium-232 led to possible pre-detonation. Separating the uranium-232 from the uranium-233 proved very difficult, although newer laser isotope separation techniques could facilitate that process. Less nuclear waste. There is much less nuclear waste when thorium is used as a fuel in a liquid fluoride thorium reactor, up to 2 orders of magnitude less, state Moyer and Teller, eliminating the need for large-scale or long-term storage. 13 Chinese scientists claim that hazardous waste will be 1,000 times less than with uranium. The radioactivity of the resulting waste also drops down to safe levels after just 1 or a few hundred years, compared to tens of thousands of years needed for current nuclear waste to cool off. However, the production of activation products and fission products is broadly similar between thorium and uranium-based fuel cycles. Fewer reaction startup ingredients. According to Moyer and Teller, once started up, a breeding reactor needs no other fuel except thorium because a breeding reactor makes most or all of its own fuel. Breeding reactors produce at least as much fissile material as they consume. Non-breeding reactors, on the other hand, require additional fissile material, such as uranium-235 or plutonium, to sustain the reaction. Harvesting weapons-grade plutonium. The thorium fuel cycle is a potential way to produce long-term nuclear energy with low radiotoxicity waste. In addition, the transition to thorium could be done through the incineration of weapons-grade plutonium, WPU, or civilian plutonium. No enrichment necessary. Since all natural thorium can be used as fuel, no expensive fuel enrichment is needed. However, the same is true for U-238 as fertile fuel in the uranium-plutonium cycle. Efficiency. Comparing the amount of thorium needed with coal, Nobel laureate Carlo Rubbia of CERN, European Organization for Nuclear Research, estimates that 1 ton of thorium can produce as much energy as 200 tons of uranium or 3,500,000 tons of coal. Fail-safe measures. Liquid fluoride thorium reactors are designed to be meltdown-proof. A fusible plug at the bottom of the reactor melts in the event of a power failure, or if temperatures exceed a set limit, draining the fuel into an underground tank for safe storage. Mining. Mining thorium is safer and more efficient than mining uranium. Thorium's ore, monazite, generally contains higher concentrations of thorium than the percentage of uranium found in its respective ore. This makes thorium a more cost-efficient and less environmentally damaging fuel source. Thorium mining is also easier and less dangerous than uranium mining, as the mine is an open pit, which requires no ventilation, unlike underground uranium mines, where radon levels can be potentially harmful. Summarizing some of the potential benefits, Martin offers his general opinion. Thorium could provide a clean and effectively limitless source of power while allaying all public concern. Weapons proliferation, radioactive pollution, toxic waste, and fuel that is both costly and complicated to process. 13 Moyer and Teller estimated in 2004 that the cost for their recommended prototype would be well under $1 billion, with operation costs likely on the order of $100 million per year, and as a result, a